Here we're going to look at question 2 from section 1 of the NSAA 2018 paper. In this question, we're given the following speed time graph for a bus moving in a straight line between bus stops. So we can see that initially it takes the bus 20 seconds to reach a speed of 12 meters per second, which it maintains for 60 seconds until at a point 80 seconds after it took off, it decelerates back to a speed of 0 meters per second after a total time of 120 seconds. So what the question asks us to do is find the average speed of the bus across this period of 120 seconds, which we're calling V. So if you'd like to have a go at this question yourself, then please pause the video now, otherwise we'll have a go at it. So to go about solving this question, it's probably best to try and think about which equations might be useful. So in this case, we're dealing with a speed and some time. So one of the equations which connects these, and is generally really helpful now we have these two variables, is that speed equals distance divided by time. So let's try and think if we can work out a way that this is going to be useful for us in this question. So what we're trying to find is the average speed. So it's the speed that the bus does on average across the whole distance in the whole time. So the average speed, V, is going to be given by the total distance divided by the total time. Now we know the total time is going to be 120 seconds, so all we have to try and find is the total distance to give us V. And we know from this same equation up here, that speed equals distance divided by time, that the distance the bus travels at a certain point is just given by its speed multiplied by the time it's been travelling for, which of course is going to give us an area underneath this graph. So, for example, the total distance that the bus travels in this time is just the area under this whole graph. So what we can do, label our three different areas onto our graph to make it into some nice easy shapes. We've got a triangle, a square, and another triangle. And then in which case then our average speed V is just going to be given by these three distances, these three areas, divided by our total time, 120 seconds. Now another way that you could find the total distance, or the area underneath the graph, is just to use the trapezium rule. But you'll see that this actually gives you the same answer as we get by thinking of these as distances, using our speed times time equation. So we need to find distances 1, 2, and 3, or S1, S2, and S3, which is going to be quite easy since this is just a nice basic triangle, so the area is just half times base times height, and this is just a rectangle, so the area is just the height times the base. So doing this, we find that S1 is just a half multiplied by 12 by 20, S2 is just 12 times by 60, and S3 is just a half of 12 times 40, all divided by total time of 120 seconds once again. So to try and work out what this is going to be without a calculator, we can probably, or the easiest thing to do at least, is to divide by 10, just to get rid of some factors of 10 out of this. It'll make it a bit simpler and make the numbers a bit smaller. So doing that and multiplying by our halves, we get this fraction here, which of course is then just some basic multiplication to give us the total, or the average speed is just 12 plus 72 plus 24, all divided by 12, which is exactly the same as 108 divided by 12, or 9 meters per second. So this is just going to be our final answer, and it's going to correspond with answer E given in the question.